Hey guys and girls, Coach Gu back again with another fun-filled, action-packed, non-flipped Algebra 2 classroom video today. Unit 2 notes number 2 is going to be about the attributes of absolute value functions. So really we're just going to be doing a bunch of examples of absolute value functions and seeing what kind of attributes we have for different types of absolute value functions. So first off though, we've got a little note here. This is very important that you understand. A straight up and down line has the equation of x equals a number. And the examples over here, you see on this graph, we've got a straight up and down line at where's the location of this line? X equals 2, and that's literally the equation of this line. It'd be x equals 2. So let's do a different example. What if my line then was over here? In that case, my line would be x equals -3. You see, because the location of this line is at x equals -3. Make sure you understand that a straight up and down line has the equation of x equals a number. Alright, so let's jump straight into some examples then and see what kind of things we're going to be looking for. So we're going to graph the function f of x equals the absolute value of x plus 2. So let's just choose some values here. Let's go with -3, -1, 0, 2, and 4. Let's just choose these numbers. Okay, so let's plug them in then. F of -3 equals the absolute value of -3 plus 2. That's going to be, absolute value of -3 is just 3, so it's 3 plus 2, which is 5. So this is 3 plus 2 equals 5. So the y will be 5. What about -1? F of -1 equals absolute value of -1 plus 2, which is going to be 1 plus 2. That's going to be 3. What would f of 0 be? F of 0 equals the absolute value of 0 plus 2, which is going to be 0 plus 2, which is 2. So we have 0, 2. And now for f of 2, that's going to be absolute value of 2, plus 2, which is going to be 4. And then f of 4 is going to be the absolute value of 4 plus 2, which is 6. So let's plot these points then. -3, 5, -1, 3, 0, 2, 2, 4, 2, 4, and 4, 6. 4, 6 up here. And so let's connect these. Remember, the absolute value graph, as we saw yesterday with the parent function, is always going to look like a V. So we know that when we connect this, it should look like a V of some sort. And if it's not, then we did it wrong. Boom. And let's go this other way now. There we go. So this is my graph of f of x equals the absolute value of x plus 2. So now let's find everything that it wants us to find. Let me erase this stuff. Alright, now the first thing it says to do right here is draw and label the axis of symmetry. What the heck does that mean? An axis of symmetry is the line that cuts this graph exactly in half. It's the line where this graph flips over and makes a mirror image of itself. And we can see that that line would be, I'm going to do it in red, would be right here on the y-axis. Look at this. The y-axis right here, that is the axis of symmetry. You see how it's cutting the graph exactly in half? That's the axis of symmetry. And what would the equation for this line be? Remember, it's just going to be x equals a number, so the axis of symmetry here is x equals 0. Now let's look for the domain. The domain is going to be from -infinity, because it's going left forever, to positive infinity. The range, what's the lowest point? It's actually positive 2. Oh, bracket, what am I thinking? Haha, bracket 2, and it's going up towards infinity. The x-intercept, where does this graph cross the x-intercept? Where does it touch this x-axis? Nowhere. So there is no x-intercept, none. And where's the y-intercept? Remember, it's a point, and it's right here, which is 0, 2. 0, 2. And that's our first one. So let's try another one, number 2. This time the function is f of x equals x minus 1 plus 2. So once again, let's pick some points. So this time let's go with negative 2, negative 1, 0, 1, and 2. Okay, so let's start plugging the points into x and see what our outputs are. So f of negative 2, f of negative 2. We're going to substitute that in for the x. That's going to be absolute value of negative 2 minus 1 plus 2. What's negative 2 minus 1? That's negative 3 plus 2. What's the absolute value of negative 3? Positive 3 plus 2. That's going to be 5. So at negative 2, we've got 5. Okay, let's go to the next one then. F of negative 1. F of negative 1. Negative 1, absolute value of negative 1 minus 1. Plus 2. What's the negative 1 minus 1? That is negative 2. Plus 2. What's the absolute value of negative 2? That's positive 2. Plus 2. So 2 plus 2 is 4. Alright, let's do f of 0. F of 0 is going to be the absolute value of 0 minus 1 plus 2. What's 0 minus 1? That's negative 1 plus 2. What's the absolute value of negative 1? That's positive 1. Plus 2, and so we can see that at 0 it's going to be 3, so 0, 3. Alright, now about 1. F of 1 is going to be the absolute value of 1 minus 1 plus 2. What's 1 minus 1, y'all? That's 0, so now we have the absolute value of 0 plus 2. Absolute value of 0 is just 0, so 0 plus 2, and that's going to be 2. Boom. And then lastly, f of 2 is going to be the absolute value of 2 minus 1 plus 2. What's 2 minus 1? That's going to be 1. Plus 2. Absolute value of 1 is just 1 plus 2. And 1 plus 2 is 3. Alright, so let's graph these points then. We've got negative 2, positive 5. We've got negative 1, positive... Okay, messed it up. We've got negative 2, positive 5. We've got negative 1, positive 4. We got 0, 3, 1, 2, and 2, 3. Okay, so remember we know that our graph looks like a V, so let's connect the points and we can see that, boom, there's one part of it, and then the other is going to be like this, boom, there it is. Okay, so let's go ahead and draw and label the axis of symmetry. So which line makes this a mirror image? That's going to be right here. Boom, 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 boom. That's my axis of symmetry. And what is the equation for this line? It's going to be x equals 1. Alright, now for the domain, once again, it's going to go from negative infinity to positive infinity. The range, what's the very lowest point? It's positive 2, and it goes up forever to positive infinity. The x-intercept, does this cross the x-axis anywhere? No, it doesn't. There is no x-intercept. And as for the y-intercept, we can see it's right here. And that's going to be at 0, 3. Looking at the picture. And there we go. Alright, looking at the next one. Now we're going to be finding the maximum value and minimum value on a certain given interval. So first we got to graph this function. Okay, so let's just pick some points. We're gonna go, let's go with negative 2. So x, f of x. Let's do negative 2, negative 1, 0, 1, and 2. Okay, so f of x is just going to be absolute value of x minus 2. So if I plug in negative 2, so f of negative 2, that's going to be the absolute value of negative 2 minus 2. This is just going to be positive 2 minus 2, which is 0. So we can see that negative 2 is going to be 0. Alright, now if we plug in negative 1, it's going to be negative 1. If we plug in 0, it's going to be negative 2. If we plug in 1, it's going to be negative 1. If we plug in 2, it's going to be 0. So let's plot these points. Negative 2, 0. Negative 1, negative 1. 0, negative 2. 1, negative 1. And 2, 0. Connect these points to make our graph. Boom. Oh, all the way. And... Boom, all the way. Okay, so now we're gonna draw our interval. Okay, so the interval I'm doing orange, and it's from -4 to +2. So from -4 is over here, and +2 is right here. All right, so first we're gonna find the domain and range. Okay, but the domain, we're talking about the domain on the interval. So the domain on the interval is just gonna be -4 to 2. That's literally my interval because we're cutting it off right there. All right, what is the range on my given interval though? The lowest point on my given interval is gonna be at -2. And the highest points on my given interval we can see is right here, which is at +2. So -2 to +2. Okay, so what's my minimum then inside this interval? Well, pretty much it's given by my range. My minimum is -2, and my maximum would be +2. And you can see that by actually looking at your graph as well. The minimum is right here, down here. That's -2, and the maximum, the highest point in the interval is up here at +2. That's it. All right, so now down here on number 3, we're given the function f of x equals 2 times the absolute value of x. And then we've got to find the minimum, the domain, range, minimum, and maximum on this given interval. So let's plug in some points. Let's do -2, -1, 0, 1, and 2. So we can see the function is absolute value 2 times absolute value of x. So f of x equals 2 times absolute value. 2 times absolute value of x. So let's see what our points would be. Then f of -2 is going to be 2 times the absolute value of -2. The absolute value of -2 is +2, right? So this is actually going to be 2 times 2, which is 4. Now let's find f of -1. f of -1 is going to be 2 times the absolute value of -1, which is 2 times +1, which is 2. f of 0 is going to be 2 times the absolute value of 0, which is the same thing as 2 times 0, which is 0. f of 1 is going to be 2, and f of 2 is going to be 4. So let's plot these points. We got -2, 4. We got -1, 2. We got 0, 0. We got 1, 2, and 2, 4. Let's connect these points and make our absolute value function graph. Boom. The v, oh, it looks a little narrower this time. Wait a second. All right, and then let's find the domain, range, minimum, and maximum over this interval. So first let's draw our interval. It's from -2, so that's over here, to +1, so that's right here. Okay, so my domain now is going to be exactly that interval, -2 to +1, because we're only looking at the interval. The range, what's the lowest point inside that interval? That's going to be 0. And what's the highest point inside the interval? You can see that's going to be right here at +4. So then my minimum is just going to be the lowest number on my range, which is 0. And my maximum is going to be the highest number in my range, which is 4. So you can see that matches up right there. Now let's look at number 4 then. This is the final one. We got f of x equals the negative absolute value of x. So watch this. Let's pick the same points. Oh, shoot. Let's pick some points then. -2, -1, 0, 1, and 2. And let's find the y values, or the f of x values. So f of -2 is going to be the negative absolute value of -2. So it's going to be negative. What's the absolute value of -2? +2. So look, whoa, it's just -2. Wow. Okay, f of -1 is going to be the negative absolute value of -1. What's the absolute value of -1? That's +1. And we have a negative sign right here. Bring it down. Oh, -1. Whoa. F of 0 is going to be the negative absolute value of 0, which is still just going to be 0. All right, f of 1 is going to be the negative absolute value of 1. What's the absolute value of 1? It's positive 1, but we have a negative sign, so negative 1. And lastly, we've got f of 2, which is going to be the negative absolute value of 2. What's the absolute value of 2, guys? It's 2, but we have a negative sign, so negative 2. That negative sign is in front of the absolute value sign, so we take the absolute value first, and then we just stick the negative sign on whatever we got. So let's plot our points. Then we got negative 2, negative 2. We got negative 1, negative 1. We got 0, 0, 1, negative 1, 2, negative 2. And we can see that this is still a V shape. It's just upside down. All right, let's look at the interval that they told us. The interval here is from 0 to 3. So let's draw that. 0 to positive 3 right here. All right, what's the domain then on this interval? The domain is the interval they gave us, 0 to 3. And what is the range of this interval they gave us? The lowest point, the very lowest point we can see is right here. And that's at negative 3. And what's the highest point on this interval? That's right here. And that would be 0. Talking about range, right? That's the y values. Okay, so then the minimum, what's the very minimum on this interval? It's the lowest number in the range. It's that negative 3. And then the maximum is the 0 within the interval. And that's how we do these problems with different versions of absolute value functions. And that's going to conclude these notes, guys. So see you in the next one. Peace!